Lesson 5-8 is on scale drawing and scale models. Our learning target for today is I will make comparisons between and find dimensions of scale drawings, models, and actual objects. These will be the terms that you'll be seeing, some new terms for this lesson. Starting out, a scale drawing is a two-dimensional drawing. So it's flat, it's on a picture that accurately represents an object. The scale drawing is mathematically similar to the object. So we're using this word similar a lot in this chapter. So again, similar means proportional, which means we'll be setting up proportions again to use scale drawings. Now, in order to do that, we'll have to be given a scale. A scale gives you the ratio of the dimensions in the drawing to the dimensions of the object. So you're comparing like the fake to the real, or the whatever they have in the drawing to the actual object. All dimensions are reduced or enlarged using the same scale. Scales can use the same units or different units. So that means you might see something that would be inches to feet, or meters to kilometers. Those are some common things you might see where they have different units, or it could be inches to more inches. So if you ever see something that doesn't have labels, we are free to assume that those are the same units. So if the problem was talking about feet, this would be like 1 foot to 20 feet. If the problem was talking about miles, it would be 1 mile to 20 miles. So whenever we don't see a label for this, we can assume that the labels are the same. Other times you'll see 1 centimeter to 1 meter. In that case, we're going to assume that, we can just know that the centimeters are on top, meters are on bottom, and it is okay to leave them different. That's just fine. But when you're making your second ratio, just be consistent and keep inches together with feet, and same thing. So inches on top, feet on the bottom. So just key thing here is that when you see things without labels, we assume they are both the same thing. So starting out, the length of an object on a scale drawing is 2 centimeters and its actual length is 8 meters. The scale is 1 centimeter to what? What is the scale? So you're just trying to figure out what this is, make a proportion like you've been doing for a while. So we're going to set up 1 centimeter over x meters. So oftentimes we'll put the scale on the left. It doesn't really matter. You could have put it on the right, but we're setting up the fake or the drawing on top and then the actual on the bottom. Now what we do know is that in the drawing it was 2 centimeters, that goes on top with the other centimeters, and then 8 meters on the bottom was the actual. Now from here you can solve it however you would like. Cross multiply, find a unit rate, look for a pattern and a multiplier, doesn't matter. Either way you'll get an answer of 4 for x, which would be 4 meters. Try this one and see how you do. Hit pause, and we're back. Hopefully that went well. Alright, here's another one. Under a 1000 to 1 microscope view, an amoeba appears to have a length of 8 millimeters. What is the actual length? So in this case, they don't give labels here, but in the problem they talked about 8 millimeters, which means everything is going to be in millimeters. Now also, we know in a microscope it's making things appear to be larger than they actually are. So again, the top number is the fake or the unreal part, the bottom is the actual. Now what you're seeing is not real, so that goes on top, 8 millimeters, and then 1 on an X on the bottom. From there you can solve it however you would like. So 8 thousandths of a millimeter. Try this one and see how you do. Hit pause, and we're back. Alright, so those were all scale drawings because they were flat, they were just pictures. Now another way you can use scales is in a scale model. This is a three-dimensional model that accurately represents a solid object. So think models like a model car, model train, model house that you're looking at. These are all not just pictures, they're an actual object. And once again, they're similar, so we can still use proportions to the actual object. So, the model of a 27-foot tall house was made using a scale of 2 inches to 3 feet. What is the height of the model? So once again, set up what you know. Your scale is 2 inches over 3 feet. They actually converted this one into all inches, which we don't actually have to do, but that's fine. And they did this to reduce it. We don't have to actually do this. You could have kept it just like you saw it from before, but just another way of looking at it. And then from there, we would compare 27 feet on the bottom to find the height of the model. That would have worked out just fine. They're just showing you a little different way. It still will give you the same answer of 18 inches for the model. Try this one and see how you do. Hit pause, and we're back. Once again, they're just making a scale that has the same units. You don't have to do that as long as you stay consistent with your labels. Either way, you should get a height of 48 inches. Okay, another science question. A DNA model was built using the scale 5 centimeters to a lot of zeros, 1 millimeter. If the model of the DNA chain is 20 centimeters long, what is the length of the actual chain? Find the scale factor. So again, you're just trying to compare real with real and fake with fake, or drawing with drawing. This one isn't the greatest example, but again, they're still doing the same thing where they're setting it up to be without labels. We don't have to do that. Just do what you did before. Keep your labels consistent. All right. You can try this one if you want, but we can move on. And that is all.